Hello and welcome back to Compiler Programming. And I think today is finally the day to make a hello world program. This will require a few changes, I guess, to what we have already, but we can start with the test case. And I think right now I will just use standard printf function for hello world, but later on we might consider switching that up to use native Windows APIs and call them directly. But that call is a bit more involved, and for now let's just do something simple. Should say hello world. Great. Okay. So literally what we are doing right now is doing this. Printf hello world, right? This is what we are trying to do. But for that to happen, we need to have two things. First, we need to be able to point to this printf function from our code. That I think this is something we can do rather easily. And the second thing is we need to be able to somehow specify the string type or array type. It doesn't really matter which one we choose for this. I mean, they are basically interchangeable for our purpose. So this is what we have to do. Now, we obviously want a function builder. We don't want any arguments, so we will kind of hard code whatever we need to do inside the function. And then function type will be, I guess, void to void. I'm not sure this is what I've called this, but we'll figure it out. Okay, let me open this up and see what we've got. Okay. We also need, what do I want to open? Yeah, I wanted to open prelude because I want to check if we have this type. We do have this type, so it's fine. Great. And I think let's start with to check if this function even works right now, right? Because this is supposed to do exactly nothing, but this is sort of what we want at the moment. And if you might have noticed that there is now this value as function thing that I added between episode, just as a helper to do this typecasting, because we constantly need to, like, when we create a value that is a function, we constantly need to access it as its immediate operand and then cast it to the function type that C understands. So I just added this little helper, which is probably just going to be used in tests. For the main code, we should not need this. Okay. Okay, result. We don't actually have a result because nothing happens and we can't really check anything because this will be just printed out to standard out, and like I don't want to get into business of mocking the stream, so like we'll just visually confirm that everything is fine when test runs. Okay, let's see how we are doing. We don't have arg2. There's also something interesting. So right now, all our functions require a return value, even if they don't actually return one. So I guess we'll have to do something like this, which is not exactly awesome, but this is not what we're working on today, so let's just fix it later. I'm just gonna copy paste add dummy return value and use it. Dummy return is better. It is better, but obviously we should not be calling a function that does not accept any arguments. Okay. Build was successful, but for some reason it's super long. Okay. It seems to be better now. Let's run the tests. Everything is fine, but obviously this test is passing even though we're not actually doing what we said we were going to do. Let's work on that then. What that would look like. We have several options for how we're going to store this string, right? Because traditionally when you compile a program to native executable, things like strings go into a special section in the executable that is marked as constant memory when it's loaded by the operating system, so that you cannot change that part. And this is why actually the type of string in C is const char, saying that you can't actually change this stuff. Another way, and I think this is what we will do for now, is we'll just put it on a stack, and this is optimization that C++, I believe, also does. So when the string is small, it puts it on a stack. Although, now that I'm thinking about it, would be nicer if we had... So let's actually start by making it work and then improve in what part of the call is actually done inside our code and what is kind of wired indirectly from C. So to make that happen, we actually need to have a value that is wrapping printf function. So maybe it would be worth it to create some kind of helper for that as well. But for now, maybe let's do that inline. So what that would look like. So we need another function. Maybe not actually. We need a value, printf value, which is what exactly? So operand is the simple part of it. It's just immediate 64 of cast to 64 bits of printf. So we just basically taking the address of that function. And for the descriptor, this is going to be a bit more involved. So the type of the descriptor is descriptor type function, and then the function part of the descriptor is as follows. We right now cannot represent periodic functions, but for this example it's not even necessary. So let's just pretend that printf accepts a single argument whose type is the next thing that we're gonna probably change, but for now we just say that it's immediate 64. In reality, like, this is what's going to be encoded as, But since we started to work on more high-level types, we will need to introduce a pointer type. So let's do that. Function. Already don't remember how it is. I think it's argument list, and this is printf arg, which we need to add now. Value printf arg. As I mentioned, this is where we will need to change some stuff. So it should be type is descriptor type pointer, but for now we will just ignore that, and instead we say it's an integer. Okay, and then the operand is it's RCX, right? So it's stored in that register. I think I can copy paste it from some other place, namely from here. Actually, I don't need to. I can just use RCX. I forgot that here it's not the value, it's actual raw operand. Okay, RCX. Great. Argument list is that. Argument count is 1. And we also need returns. And here we again have the same problem as with here. So I guess let's use this dummy return in both places. But this is definitely something we need to fix. So let me add the fix me should support functions that do not return a value. Great. So this is fine. But this will not build because we are not using the value. So let's check it now. It doesn't work. Missing semicolon before identifier. Yes, you are right. I am missing that. Now I have an extra one here. And now everything is fine. But we are not actually using this function. So here we now need to call it. And right now I'm just gonna say that our message is hello world. And we need to create a value for this. Value message value is, and again it's the same deal as here. Actually this should be, no, here, yeah, it's the same as this one. And as operand we just say that it's an immediate 64 that is message. And again, we need to cast this to S64 so that C is not angry at us. Okay, we have our argument, and now we need to do this, call function value. What does call function value do? It will be printf value message value and 1. Basically, it also accepts and I changed it around after the last video, so it accepts an array of arguments or array of values, and then the parameter saying to us how many arguments we have actually passed. Let's check. Too few arguments. Indeed, it also needs to have a builder. Now everything is fine. And let's see what that results in when we try to run the tests. Well, it looks like we output hello world not once but twice, and then crash. That does not seem to be what we wanted. So let's, I guess, get dev environment and see what is going on. Okay, we'll jump straight to here. Let's run. And okay, let me now I want to go to disassembly, and I guess this is the one that we want. Okay. This is fine. We are this is the memory for our const char. So if I do this, it actually works, right? So we have, this is correct argument that we are putting into RCX. Then we have we move the printf function into the right place. So where does it crash? Okay, this is the first hello world. Why? Wait, this is very strange. So yeah, it looks like when we call printf, it actually stomps over the return value that should be there, which is kind of strange. I guess the way we are making a call is not 100% compliant with what we want. Not sure what to do about that. Because if we go into that rabbit hole of debugging, that's gonna be quite a long one, but I guess let's try. Let's first start with trying to understand what the call to printf might look like from a normal code. Hello world, and we need to include dio.h, I believe, or is it like this? So it was like this. Compiling? Okay, yeah, it is. So let's check what that generates. We don't need this anymore. And I actually do not want OX as well. I want the debug version of this. Ooh. That does not seem like fun. So it looks like printf is an intrinsic and it is actually inlined. Yikes. I don't remember. Is there a way to output a string in C without using printf? C, right, string. Is it like puts? What is that? I don't want your cookies. Okay, so we actually have puts, and we might have better success with that one instead of using printf. So let's try puts. Puts. And before we actually do that, let me check if it is better than the printf. Okay, this is much better because it doesn't actually generate any intrinsic stuff, and it's a straight up call. And here what I was explaining before about the different the way functions are stored. So as you can see, it's stored in a different block, and then you just reference it back to that area when you call through this load effective address instruction, which is something we will need to implement later on, but for now we don't need that because we are just always passing actual addresses from our C code. Anyhow, returning to our puts stuff, let's see if that will have better success rate than what we had before. Let's try it out. And now it actually does work, which is great. So yeah, printf, like I was already wary of using printf when I was starting these videos, and I was like considering if should I use it or should I use it directly system calls, but for now I guess puts is a good point in between to make that happen. Okay, so we do have, we can call puts, but there is nothing new from what we had before. Would be, let's do at least a bit of new stuff and add a pointer type. In reality though, the pointer type will be exactly the same as an integer type. So I think I literally just do this, do pointer, and everything will work because we are not actually using integer type for any tests. Would be nice though if the pointer type actually told us what does it point to. For that, we need to do this and say that struct descriptor pointer 2, right? So this way we can have this structure that is going further. And I think this is not allowed, so for the pointer 2, this needs to be an argument, otherwise we will just create an infinitely big descriptor, which is not great. Okay, so we have this pointer to stuff, and we can actually use this here. Although, again, it will not matter much at the moment. So pointer 2, and then we say that this is gonna be but we can at least lay out the types. So value this way. Message value is this. Pointer to pointer 2. So we need to have this descriptor, which is going to be message descriptor. It has type. And this is, again, where we need to introduce a new type. Because the type of this is an array, right? Descriptor type array. And we will probably, and for arrays, what I mean is, maybe it should be more explicit that I'm talking about fixed size arrays. Descriptor fixed size array. And the array knows about its length, and it also should know about the type of the items of this array, right? So again, it is gonna be like this. See if that builds. It does not, because here I'm missing stuff. Descriptor type fixed size array. Then we say that this is, I believe I did not actually add it to the main type. Yeah, so we say that it's descriptor fixed size array. And array now is this, right? So for the length, we can do str len of message +1. The reason it is +1 because it, I can actually say null terminator. So because there is actually a 0 at the end here. And then item is, and this is where we actually come to the point where we will need to introduce sizes to descriptor integers, I guess, because we don't really have a value here, but we do need to specify somehow that it's basically bytes. For now, though, this is just gonna be this stuff. Cannot convert descriptor to descriptor star. Okay, let me pointer to then message descriptor. So at least this one we can fix. And yeah, we can't see, put an item as a thing here. So we need a separate descriptor item descriptor. This. And yeah, again, none of that actually does anything, but I just wanted to, in this video, to do the kind of the basic scaffolding of what we will need to have to make this stuff work. We could try to make a code that copies this message on the stack, but to be honest, since this is not really how we're gonna store things long term, I don't see a big point of it. So I think this is enough for now. I'm not sure if I will do it between the videos or I will make a separate cleanup video, but as you can see, we are starting to accumulate quite a bit of craft here, and also it becomes a bit too inconvenient for my taste to create all of these different structures. So maybe one thing that I will do in the next video is allow me to generate, for example, this stuff out of the function definition, so we don't have to do it manually. Maybe that's going to be a good video. But that's later. For now, thank you very much for watching and see you next time.